Both of these, this is a continuation of chapter 5, section 4, the fundamental theorem of calculus. Both of these, D and E, go straight from the table, from the charts. Because what you have to look for, if you have one on top and then a function of x on the bottom, it's x plus a. The integral of this is simply the natural log. Because if you think about it, you notice the x doesn't have an exponent. Because if it did, then we'd have to have some sort of constant up there and a value of x. But it doesn't. So the reason, why do we put absolute values around the x plus 1? Right. The domain of ln is what? The graph looks like this. So what's the domain? No, because you cannot have negative x's. You cannot have 0. So the domain is x is strictly greater than 0. So the ln cannot be of negative, it cannot be of 0. Those are undefined. So this value here has to be greater than 0. So it can't be negative. That's why I put absolute values. Because if x is negative, then if we have the absolute value, it changes to positive, and we're in good shape. So now what do we do? So now what we do is once we take the integral of this function, we found it equals, well, in your table, have you found wish I would have brought my tables. Number 18 or something like that. Yeah, so look for the integral of something equals ln absolute value of that. It's probably going to have plus c at the end of it. Okay, and that's what we're going to talk about in the next section, why that plus c is there. So once you find the ln plus c, look what the integral looks like. It probably, so what does it give you? It gives you du over u. So yeah, so the integral of du over u is equal to the ln of u plus c. So in our example, does it match this? What is our u in our equation? X plus 1. It's the bottom. What's the derivative of u? 1. And since it's a function of x, it's 1 dx. So it's really dx. So that's exactly what we have here. On top, it's dx. On the bottom, it's x plus 1. So it's u du, according to this substitution method. So far, so good. So again, that's the hardest part, is finding out where does that integral fit into in that chart of things. It's not going to be x's, it's going to be u's and a's. That's what you have to look for. The a's are the constant, the numbers, and the u's are functions of x. So this one, how do we take the integral? We took the integral of dx over x plus 1. We got ln absolute value of x plus 1. Now what do we do? Once we take the integral, we're still bounded by the lower bound of 0, and so this is on a closed interval of 0, 1. That's what that means. So what we do is we take the x of the top first, put it in there, minus put in the lower x. So I put this one in first. Again, it's all going to fit into place when I formally define it in the next two sections. So the 1 plus 1 equals 2, and 2 is a constant number, so it can't change. So I just put ln2. 1 plus 0 is 0 plus 1 is 1. What is the ln of 1? 0. Because the log, the property says the log of any of 1 is always 0. So our answer is ln2. So that's what we got for the first one. We do the same thing in the second one, because if you notice, it's kind of the same situation, except what happens on this one. X is squared. So now we look at, is this number a perfect square? Yes, in this case, it's 1 squared. So what you're going to do, you're going to look under your you're going to try to find that in your table. du over u squared plus a. So what is u? U is x. No, but this is x, so it's u squared. So u is x itself. That makes du is 1 dx, which is what we have on top. So now where do we have in our table this setup? What does that equal? This. Because is our numerator dx? Yes. That's the derivative of the bottom. Since u is the x, so what does that equal? What table, what do we see? Do we see this anywhere in the table? That's going to be the inverse tangent, I bet. The inverse tangent of what? Of u over a. So what is u? Is x. What is a? 1. So it's the inverse tangent of x over 1 from the bounds of 0 to 1. So we have the inverse tangent of 1 minus the inverse tangent of 0 . Remember how inverse tangents work? Or inverse trig functions work? What this is asking is what angle makes tangent equal 1? What angle theta makes tangent equal 1? That's what you have to think backwards of inverses. So tangent's 1 whenever the sine and cosine are the same, which is at pi over 4. Also, it equals 1 in the third quadrant, but that's outside of our realm because we're going from 0 to 1. What's tangent of 0? Tangent is 0 at which angle? Yeah, 0 and pi over 2. But again, we're in from 0 to 1, we're in the first quadrant. So it's 0. So our answer is pi over 4. So far, so good. All right. So let's look at what are the uses of finding, why do we find integrals? One is the area under a curve in some closed interval, or actually it doesn't have, we'll find out it doesn't have to be a closed interval. Is there another reason we use it? As a rate of change, as a rate. Not really a rate of change, because rate of change defines slope. What I'm talking about here is moving motion problems, which is what we're going to talk about next. And another one is what? So when we talk about this, we're talking about a displacement. And the last thing, so this is like in physics, motion problems. A car moving on a street, a rocket shooting up, a rock falling. Anytime you have a moving motion problem. The last one we look at are what we call net change. This is typically in a business or economic sense, is how much, what is the net change of this, our profit margin or our productivity level or customer base? What is our net change? That's what we'll look at there. We just talked about areas under the curve. So let's look at integrals as a rate. We had 4 terms that we defined. Do you remember what they meant? And how they relate to each other? What does S represent? Nope. Position. It's a position function. So the position of the vehicle at t equals 0 or t equals 3. What is v? It's velocity. How does that relate to position? And how fast is acceleration? This is the change of your position. It's the first derivative of your position function. Because you don't have a velocity unless you go from point A to point B divided by how much time it took you to get there. That's what velocity is. Velocity and speed are the same thing. Except we just like to call it velocity. What is it? What is this next one? This one's acceleration. What is that related to the previous ones? It's a change of velocity, which means it's the first derivative of velocity, which makes it the second derivative of your position. It's the change in the change of your position. And what's this one? Jerk. And that is the change of acceleration, which is the second derivative of your velocity, which is the third derivative of your position. Now, how does these are derivatives? How do derivatives and integral relate to each other? We start off with a function, we take a derivative, we get f prime. We take a dy dx. That's a derivative. Integrals, we start off with the derivative, we take the integral, and we get back to the original function. They're inverses of each other. So the integral of acceleration will give us velocity. The integral of velocity will give us position. All right, let's look at some examples here. Oops, where's my position? Well, it's so we start off. I'll start with x. We start off with a derivative. When we take the integral of this, we get back to the original function. Or we just say little f if you want to keep it in the same terms. But once we took the integral of the function, we still have to look at what are our bounded limits, our closed interval. So we start with the top and minus the bottom. This is the second fundamental theorem of calculus. This is part 2 of it. It says whenever you have a function and you take integration of it, the integral of it, you get the original function as the difference of the two bounds. There's also another corollary to this. That the derivative of the integral would equal what? What you started off with. Because remember, so let's find, if we took the integral of acceleration, what do we get? Velocity. It goes back one. Then we take the derivative of velocity, we get what? Acceleration. Look at all these things we had here. Going this way are derivatives. So if I had acceleration and I took the integral, I'm going back one. But that's the first part. Then if I took the derivative of that, what do I get? Back to acceleration. This is the derivatives. This is integral. So if I take the derivative integral, if I take the derivative of an integral, I get the same thing. That's what it's saying. If I take the derivative of the integral, I get the same thing. Nothing changes. Basically, you say that these cancel. So far, so good. Another thing we can do with this. What do these terms mean? What do these terms represent? Okay, but then now when you subtract them, what do you get? The difference in height. What is f of b? The height of the rightmost. Yeah, so this is the rightmost height. This is the leftmost height. The subtraction of the two gives you the difference of the two heights. So this is the end value. This is the beginning value. So let's say we had this f of a to f of b. What is the distance between these two? The integral. Because it's f of b minus f of a. It's the difference of the two. So we can find the end value. We can find the end value if we have this equation. Because this is the width between the two. Let's call that m. So if I start off at 5 and m is 3, what's the next one going to be? Because if my integral, my m is 3, that means this distance is 3 units wide. F of b minus f of a equals m. Not the slope, but some number m. It's the distance between the two. If I'm saying that the f of a is at 5 and my m is 3, then what's my f of b value? I start off at 5, I add 3, I get, so 5 plus 3 equals 8. So we can find, with this equation, we can find the end term that we're looking for. All right, so let's look at examples of, example 5 deals with motion. Consider again our analysis of the heavy rock blown straight up from a dynamite blast. We did that in example 2, section 1. The velocity of the rock at any time t. So the velocity of the rock at any time t is given by the equation 160 minus 32 t feet per second. So find the displacement of the rock. Displacement of the rock during time, the time interval 0 to 8. And then B. Find the total distance traveled. During this time interval. From 0 to 8. So what do we do first? Remember, what does this function represent? What's the whole picture represent? So what happened in this picture? There was an explosion and the rock went straight up and then it has to come straight down. Here's the velocity function. What do we notice about this graph and how's that going to relate to the velocity? What do we notice? What's going to happen there? Yeah, there'll be a point where the velocity is 0. When will be negative? Yeah, at one point it's going to be positive and one point it's going to be negative. Now, why is that a problem? Because the distance is the same. So what's going to happen here is the same thing can happen is when we had the sine function. Or from this pi over 2. So it's negative pi to pi. If we took the area of this function from negative pi to pi, what's going to happen? Yeah, let's look at this. So from negative pi to pi of the sine function. So what's the integral of sine? Think of the unit circle. This is sine, cosine, negative sine, negative cosine. Going this way are derivatives. Going this way, integrals. So going backwards, I start off at sine, I'm integrating, so I get negative cosine. From negative pi to pi. So I have negative cosine at pi minus the negative cosine at negative pi. What's the cosine at pi? -1. So this is, they cancel each other, so it's plus. What's the cosine at negative pi? -1. Remember, here's 0. Pi is on this side. Its location is -1. It's 1 at 0 and 2 pi. It's -1 at pi. So we get +1 minus 1 equals 0. We see that the function's symmetric. The reason this happens is because part of it is negative and part of it is positive, and it's the same size. So they cancel each other out. There's one part's going up, one part's going down. So how would you fix this problem to find the true area under that curve. You could do the absolute value, or you could do what else? No, you could do two parts. You can do an integral from negative pi to 0, and then add the next half, which is from 0 to pi. Yeah, we could take the absolute value of them. Or because we know it equals 0, we could take only one half of it from 0 to pi and double the answer. Or we can use the properties. Since we know this one's going to be negative, I can switch the bounds of integration. There are a whole bunch of things you can do, but you have to be sure of what's happening. If I change the bounds of integration, that makes it, I have to change the sign of the function. It went from negative pi to 0. I changed it from 0, so I have to make it negative. So if you change the bounds of integration, you have to change the sign of the function. And that's going to get rid of the negative answers you get. So, but either way, we have to know when it equals 0. We know it equals 0 at both ends, and this one here, because this is going to cut our graph into two equal parts. So, at what time does our velocity equal 0? Because remember, velocity is the first derivative of your position. So it's the slope of your position. When is the slope equal 0? How do we find that out? Take your velocity function, set it equal to 0. Because that is your first derivative, so it's your slope. So when is your slope equal to 0? So we move the 32 to the other side, divide it by both sides. So time is equal to 5. Five goes into 16 three times with one left over. 5 goes into 10 two. So it's 32. So we know that in our interval, we have to go from 0 to 5 and then 5 to 8. Those will be our two different intervals we'll integrate by. Yes. Because we're only going to from 0 to 8. If you would create a table from 0 to 8, what do you think you'd see on this side? More so than that. Well, it's going to be opposite. If something's going straight up, does it increase in speed or decrease in speed? It decreases because gravity's always acting on it. So hopefully we'll start seeing a decrease of speed because eventually the velocity will be zero. So when t is zero, we got 160. That's the initial explosion. Then when t is 160 minus 32 is 128, and so on and so forth. Then how about when t is 6, 7, and 8? So these are all going to get smaller and smaller and smaller until it gets to 0. What's going to happen with these? When t is 6, 32 times 6 is 192. So 160 minus 192 is going to give us a negative 32 velocity. And negative again, negative again. So we see from our table that from times 0 to 5, the answers are going to be positive. And then from 5 to 8, the answers will be negative. So yes, what we could do before we add them up, we could take the absolute values of all of these. Or we could change the bounds of integration and change the sign out in front. So there's a lot of things we can do. But this, I want you to be aware that because this object goes in two different directions, you have to have a positive and negative distinction. Positive velocity going up, negative velocity going down, because it's going in a direction. So we're going to look at from 0 to 5, the equation is 160 minus 32t dt, because these are going to be positive. Now, since these are going negative, I'm not going to change these. Instead of a plus, I'm not going to subtract them. Or again, that's what you can do anything you want to, because since you know these are all going to be negatives, we could just take the absolute value of 160 minus 32t from 5 to 8. All right, so let's see what this looks like. We have the integral from 0 to 5 of 160 minus 32t dt plus the integral from 5 to 8 of the absolute value of 160 minus 32t dt. So what's the integral of 160 minus 32t? Let's look at this part here. So the integral of 160 minus 32t from a to b. According to the properties of integrals, we can dt. So how do you take the integral of something? Remember, this is the derivative. If it was a derivative, what did 160 have to be to, when you take the derivative, you get 160. What happened? What's missing? a t. So the integral of 160 is 160 t. Here's what's really happening. Right now, is that since it's dt, is there a t there? Well, there kind of is, but it's got a zero exponent. So if you just have a constant, the variable has a zero exponent, because anything to the zero power is 1. So when you take the integral, whatever that exponent is, add 1. And divide that by that same exponent. Whatever it is up here, you divide by. So this is 160 t to the first over 1, which is simply 160 t. To test this, take the derivative of this. Do you end up with 160? Yeah. So we do the same. So this is what that side equals. That's what this one equals. Now let's look at 32t. What's the exponent of t right now? 1. So the rule says whatever the exponent is, add 1. And whatever is up here, put the same thing on the bottom. So it's 32 t squared over 2. They can cancel, so it's 16 t squared. What if I gave you this? What would the integral be? What would the integral be for this one? So start off with what you have. What do you do with the exponent? Add 1. And whatever's up here goes on the bottom. So 6 goes into 3. So it's t to the 6th over 2. Yeah, if you take the derivative of this, you'll end up with that. Because the 6 comes down, that becomes a 5. Check. 2 goes into 6 3 times. Check. So that's the whole process we're doing here. So in our equation, 160, this comes all the way down here. So 160 becomes 160t minus 16t squared from 0 to 5 plus same thing, 160t minus 16t squared from 5 to 8. So far, any questions so far? I'm doing in pieces. Because you can take any polynomial, if it's separated by plus or minus, you can make them into as many as you have. So now, put the top number in there. So we have 160 times 5 minus 16 5 squared minus 160 times the lower bound 0 minus 16 times 0 squared. That's this first equation. I take this one, both t's go to 5 and both t's go to 0, plus, now I do the second equation. 160 times 8 minus 16(8) squared minus 160 times 5 minus 16 times 5 squared. Now we do the calculations. In this first bracket, 160 times 5 is 800. 5 squared is 25. 25 times 16 is 400. Minus that's 0, minus 0. Now the second bracket. 160 times 8, 1280. 64 times 16, it's 1024 minus 800 minus 400. Because this number and this number are going to be the same. They're both at 5s. (800 minus 400 is 400 minus 0. 1280 minus 1024 is 256 minus 400. So we have 400 plus 256 minus 400. 400s cancel, so we get 256. So what does that tell us? How high is the rock after 8 seconds? 256 feet. The height of the rock after 8 seconds. And part B is, what's the total distance traveled? Because the first derivative was we took the derivative of the integral. So we got the position function. We're solving for s. When we took the integral of the velocity, what we got is the position function from 0 to 8. So this tells us the position after 8 seconds. It's 256 feet above the ground after 8 seconds. Because remember, it takes 5 seconds to go up, and we only have 3 seconds left. So it's not at its highest point, it's not back on the ground, it's somewhere in between. Because this is 5 seconds, this is only 3 seconds. Now B is asking the total distance traveled during this. movement. So we're going from 0 to 8 of our velocity. Which is 0 to 5. Plus 5 to 8. I'm going to do the absolute values. So we had the same values here, so it's going to be the integral from 0 to 5 of 160 minus 32t, the absolute value. The integral from 5 to 8 of 160 minus 32t. But now, instead of looking for the entire distance, because remember, one side's going up is positive, one side's going down is negative. So we have to change the sign. Well, we absolutely valued it, so we can change it to a plus. That's great. All right, so let's see how far we travel. So this is 160t minus 16t squared from 0 to 5. And then 160t minus 16t squared from 5 to 8. Again, these are absolute values. So what we figured up here, in this first interval, we got 400. And on the second interval, we get 56. No, we have to take this difference. 256 minus 400. So 400 minus 256 is 441. So we had a total distance traveled of 544 feet. Okay, in our function, we're dealing with respect to time. dt says it's the change of time. So we're integrating with respect to time only. So there's the only variables we're looking at. These are what are called our dummy variables. They could be anything we want to, but since we're dealing with time, that's dt represents the change of time. So that's what we're looking for. So here you have the velocity of the change of time from 0 to 8. So it simply tells us that we're looking at it specifically in this domain. I have to be able to ask that, but yeah, we're integrating because later on in Cal 2, you'll have implicit functions. These are explicit functions where y equals some function of t or some function of x. In Cal 2, you'll see, actually, we did a little bit in this one, I believe, is we can have x and y as they're integrated, they're combined together. We can't separate them. So that's what we call explicit or implicit differentiation. We're taking both x and y. So what we would have to do here, we're taking a derivative with respect to x, then we take a derivative with respect to y. So that's what we're looking at here is which variable do I differentiate first? First, I look at and do all the x's. Then I look at and do all the y's next. So it tells us what we're looking for and only concentrate on those values. All right. The last of the three is called net change. Uh, Theorem 4 or Theorem 5. It's called the net change theorem. It's on your sheet. It says the net change of a differentiable function f of x over an interval AB, where x is between a and b, the net change is it's what we defined earlier. So we take the integral of the derivative, find out where it came from, then take the values of the top minus the bottom. That's what the net change is. Example 4. Here's we talked about earlier in the semester. In business, the cost value is C of x. When we take the derivative of it, it's called the marginal cost. We have profit, we have cost, we have supplies. Yeah, profit. I forgot is revenue. Profit is represented by P of x, where x represents the number of items that you produce. Revenue is R of x. That's how many items you sell. How much money you get because each item costs amount. The derivative of your profit, profit is revenue minus cost. Your profit is how much money you have different, because if it costs you $20 to make an item and you sell it for 15, you're losing money. So the profit is revenue minus cost. The derivative is called the marginal profit. And the revenue, the derivative of the revenue, the change of the revenue is called the margin. So when we look at the integral of our cost function, what that equals is the cost of making the most amount minus the cost of making the least amount. The difference of the costs. That's what the marginal is. The reason it's called marginal, it's within this margin. Same thing with the revenue and the profit. So the integral of the marginal revenue is simply the revenue of the most amount minus the revenue of the least amount. We call that the marginal revenue, the difference of the two. Next one. 6. There it is. Any questions so far? So that's what the terms are in business. They'll give you a function, you take the integral of it, and do the same thing we've been doing. So really, it only thing it does is change the name. The operations are the same. The only thing changes is depending on what you're doing, you change the name. All right, example 6. Ooh, no. What do we, the total area? How do we find the total area? Because if we just take the integral from a to b of some function, will we get the true area under the curve? Yes. Yes. If there are no x-intercepts. So is that going to give us a total area? No. So that's what we have to look at. We have to look at this part from a to c of our function. And then we have to add it to c to b of our function. But the problem is that we just ran into this part, one part's going to give us negatives. So we got to take the absolute value of those, which is what we just did. So you have to be very careful to first see when you have your interval, when you have your function, are there any x-intercepts? If there are any x-intercepts, is that x-intercept in that domain A and B? Will these two functions have the same area under their curves? ¿Por qué? That's exactly what's right. That's different. And yes, you're right, because that's exactly, if we graphed these two, this one is the x squared function, which is parabola, and it shifts down 4 spaces. So we go from -2 to 2. So the graph will look like this. We're only looking for this area. This function is the x squared, but it's pointing down, and it goes up 4 spaces from -2 to 2. But there's a problem. Let's integrate these from -2 to 2 of x squared minus 4 dx, from -2 to 2 of 4 minus x squared of dx. So we gotta find so what's the integral of x squared? Remember, what do? Add 1 to the exponent, and whatever you do there, put it on the bottom. So this one's going to be x cubed over 3 minus, what's the integral of 4? Remember, this is 4. There is no, so it's x to the 0. So we add 1. So we have 4x. And pretty much the same thing is going to happen on the other side. So we're going to have the integral of 4 is 4x, x cubed over 3 from -2 to 2. Everybody okay setting it up? Because this is the most important. Because if you don't set it up correctly, your answer is going to be wrong, obviously. So now we start with the top number. So we have 2 cubed over 3 minus 4 times 2. I take this number and put in both x's in there. Minus, now I take this number and put them in both x's. -2 cubed over 3 minus 4 times -2. Let's go and work this one out. So 2 cubed is 8 over 3 minus 8. That's 4 times 2. Minus -2 cubed is -8 over 3. -4 times -2 is a +8. Simplify these, so this is 8 over 1. So we get 8 over 3 minus 24 over 3 minus -8 over 3 plus 24 over 3. This is -16 over 3 minus 16 over 3 makes it -32 over 3. All algebra. I mean, just calculus is right there. Just setting it up. The rest is algebra. So for this first one, we got a -32 over 3 area. Let's do the same thing with this side. That's going to be 4x minus x cubed over 3. No, that's the integral. Yeah, that's already done. It's from -2 to 2. So the first one, we have 4 times 2 minus 2 cubed over 3 minus the bottom one. 4 times -2 minus -2 cubed over 3. Yeah, I went pretty quick there, but again, it's just doing algebra. There, everybody, okay, did everybody see how I set it up first? Where I got these numbers, how I got this, I take this as my first value. Anywhere I see an X, I put it in there. Then I subtract wherever I see an X, I put that in there. Then I work them out. So what do you see? If I get a negative area, it's below the x-axis. If I get a positive area, it's above the x-axis, which is why if we have an x-intercept in our function, our domain, we have to take those separately. Because if I add this and this, what happens? Zero. Do I have a zero area? No, I have actually twice that much. I have 64 over 3. So that's what I'm saying. That's very, 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 very important to see that. Example 7. Show the graph of the function f of x equals sine x between 0 and 2 pi. Compute the definite integral of f of x over 0 and 2 pi. Area between the graph of f of x and the x-axis over the interval 0 to 2 pi. Okay, so what is it asking us to find? Here's our function. Here's our interval. Find the definite. Why is it a definite integral? Is because we have bounds. We have A and B. We have a lower bound, we have upper bound. That's why it's called, if this wasn't there, it'd be an indefinite integral, and we have to put a plus C at the end of it. So the difference is this: definite integrals end up with numbers, indefinite integrals come up with equations. So A, take the definite integral from 0 to 2 pi of sine x dx. It didn't tell us to do anything else. Just take the integral of it. So what's the integral of sine x? It's negative cosine x from 0 to 2 pi. So from here, we take negative cosine at 2 pi minus negative cosine at 0. What's cosine of 2 pi? 1. So it becomes negative 1. Cosine of 0 is 1. So it's also going to be negative 1 because this negative in front. So it becomes negative 1 plus 1 is 0. Problem. If it comes 0, what does that tell us? There's equal top and bottom. So in this domain, do we have an x-intercept for sine x? So where does sine x equal 0? when x equals pi in the domain 0 to pi. So that means we got to now take our function from 0 to pi, and then we have to add that to pi to 2 pi. And we'll just take the absolute value of both. We don't have to worry about negative signs. So this gives us negative cosine from 0 to pi. This gives us negative cosine from pi to 2 pi. Again, it's the absolute value. So we get negative cosine at pi minus negative cosine at 0 plus negative cosine at 2 pi minus negative cosine at pi. So cosine at pi is 1, negative 1, absolute value becomes 1. I'm thinking absolute values. I'll still get 1 there. It's going to be 1, 1, give you 0, 0. So these, yeah, it's going to be positives. Yeah, so we take the positives of those. So cosine of pi is 1. Cosine of 0 is 1, but still it's 1 minus 1. So we have to add those because we're taking the absolute values of them. We're not subtracting them, we're adding them. Plus 1 plus 1. 2 plus 2 is 4. So the total area is 4. Area between the graph and the x-axis over 0 to pi. That is the area. Because they were both, we added both together, got both zeros. So what we just did, we just took the sign and we did it this way. From 0 to pi, from pi to 2 pi. So that was 2, that was 2. But when we take the absolute value, it doesn't become negative anymore, it becomes positive. Ooh. One more, 8. Find the area of the region between x-axis and the graph. That's redundant. When they're telling us find the area between the x-axis, it's automatically, unless otherwise noted, it's always under the graph to the x-axis or above the graph to the x-axis if it's below the x-axis. So that's redundant when they're saying find the area between the x-axis and that. So the function is going to be x cubed minus x squared minus 2x in the domain -1 to 2. So what's the first thing we got to do? Find any x-intercepts. Are there any x-intercepts within this domain here? So how do we do that? Set our function equals 0. We can factor out an x. And can we factor this one out? The second signs of minus are the opposite signs, bigger numbers. So what times what is 2? When you subtract them, you get 1, 2, and 1. So our x-intercepts are at x equals 0, x equals -1, and x equals 2. So what you're going all you have to do now, since -1 and 2 are the end bounds already, we expect those to be x-intercepts. This is the only one that we didn't know about. So we got to take our integral of our function from -1 to 0, and then from 0 to 2. Just take them, and whatever you get, take the absolute value of them, and then that'll give you the true area. So what's the integral of the first one going to be? Well, do each one separately. What's the first one going to be? X to the 4th over 4 minus x to the 3rd over 3 minus 2x squared over 2, and the 2's cancel. So we're going from -1 to 0. We'll do the same thing for the second one. It's going to be x to the 4th over 4, x cubed over 3 minus x squared from 0 to 2. Take the absolute value of that too. So the first one's easy. If they all have x's, so at 0, it's 0. Minus, now we put -1 inside each one of those. So it's -1 to the 4th over 4, -1 to the 3 over 3, minus -1 squared. That's the first side. That's this one. Two to the 4th over 4, 2 to the 3rd over 3, minus 2 squared, minus 0. So that's negative. So this one, positive 1/3, -1, negative out in front. So we have 16 over 4, 8 over 3, distribute that. -3/12 minus 4/12 plus 12/12. Did I lose you? Did I lose you? So 8, so it's 5/12 plus 8/3. We get 5/12 plus 8/3. Common denominator is 12. Oh, it's 37, not 47. Yes, 37/12. Why did this become positive? Absolute value, because one of these sides were below the x-axis, so I take the absolute value of just all the answers. So if I get a negative answer, take the absolute value of it. Now adding the areas. This is the area of the first. This is the area of the second. What do y'all think? Did I go too fast? Yes. Here? So right here. So you're okay with where I got all these right? Get a common denominator. So we have this is negative, that's negative. So -3, -4 is -7. -7 plus 12. No, 6 would have been too easy. They don't want to make it too easy for us. But no, again, it's a small number difference. Trust me, I make those all the time. And on this kind of stuff, I don't mind if you use calculator to check your answers because it's gonna suck if you go through all this work just at the very end to make one. I mean, think about it. At the very last step, you made one calculation error. All the hard stuff's already done. And so yeah, that's why I always check my answers again before I say this is it. All right, so that does it for 8 point or 5.4. Now, if let me